Welcome to MSQ series, and in this particular MSQ series we are today going to solve questions on steel structures. Yes, so we'll be seeing some important topics like welded connection and boarded connections, okay, and we'll be solving the MSQ questions. So warm welcome to all the participants. Okay, let us start the class without any further delay, but before that some announcements. Okay, so we are having various series for all the students because the GATE examination and the ESE examination is nearby. Only 2-3 months are remaining, right? And therefore we're conducting a lot of series. So in that we're conducting this daily dose series. In this daily dose series, either we are discussing a question or we're discussing what? A particular concept in 5 to 10 minutes. So daily we are having this class and morning 10 a.m. So tomorrow, okay, so tomorrow morning 10 a.m. we will have a question on shrinkage ratio. Many students have doubts in shrinkage ratio. So we're going to solve a question tomorrow at 10 a.m. So daily you can have what? In the morning, after you wake up at 10 a.m., you can tune into channel and then see the daily concept, daily dose we can say, right? Then we have this concept capsule where we are trying to cover and some important topics in 30 minutes. Yes, and this particular series will have this schedule. Yes, so the next class will be by Avinav sir, and that will be on what? That will be, the date is what? The date is given 30th of November, means tomorrow only. Yes, so tomorrow 30th of November, okay, night 10:30 p.m. Sir will be taking a session on what? Longitude and time variation. Yes, also we have running series in the app. Yes, so we have this 2024 fundamental series who are starting their preparation and 2023 rank booster series, right? So in that, tomorrow again at 8 p.m. Tomorrow again at 8 p.m. So we are having a lot of sessions, right? We are having a lot of sessions, so we are announcing all the sessions always. So tomorrow 8 p.m. Abhinav sir will be taking what? Shear strength of soil, but this will be in the app. Okay, remember this will be what? In the app. In the BYJU'S Exam Prep app, you can watch this lecture tomorrow 8 p.m. Okay. Also, this MSQ special series is going on, and today in this MSQ I am solving questions of what? Steel structures. This is the schedule, yes. And tomorrow also at 9 p.m. Yes, a lot of sessions are conducted. 9 p.m. we'll be discussing some of the important, we can say, tips for boosting your preparation in the last 2.5 months, right? Because around 75 days are left for your GATE examination. So I'll be giving you some tips. So 2.5 months approximately. Yes, okay. So we'll be seeing this session. So this was a short announcement of all the sessions. Welcome Nikki, Juhi, Samriddhi, Rasmita, Kartike, Naivedya, Arun, Lakshmi, Vivek, Akans and Saurabh. So let us start solving the questions. Okay, so today we'll solve questions from welded connection and boarded connections first. So this is the first question. Okay, I'll write the data also. Okay, this is the first question. Here two plates are welded, right? You can see the welding is done from here to here, right? And the dimensions are, this is 80 mm, this is 80 mm, okay? This dimension is 60 mm, and this dimension is 80 mm, okay? This is the weld, right? The welding is done like this, right? Then it is given the weld is of Fe410 steel, okay? And the weld size is given as 8 mm. The weld size is given how much? 8 mm. And we are solving MSQ, so these are the options given. These are the options given. Okay, what are the options? The strength of weld is given, okay. The design shear stress of weld is given, okay. And for a factored load of something, the length of weld is also given, and the effective throat thickness is also given. Now, ladies and gentlemen, I'll ask you the question that you have to select, multiple are there. So first tell me, is this D option correct or not? Can you just mention in the comment section? This D option is correct or wrong? Effective throat thickness, is it 5.6 or something else? Answer me. Effective throat thickness, is it 5.6 or something else? Please tell me. Is it correct or wrong? Yeah, it is correct. As per Vivek, it is correct. Arsenal is also telling 5.6 mm. Correct. Okay. So let me put some light on this effective throat thickness. Let me put some light on this effective throat thickness. Okay. Effective throat thickness. Okay. So whenever you have this fillet weld, I can say, suppose that the weld surfaces, okay, and you have welded like this. Yes. So this weld surface, the weld surface can be approximated as a triangle, right? The weld surface can be approximated as a triangle, right? Yes. This will be S, this also will be S, the size of the weld. Yes. And the effective throat thickness is what? The effective throat thickness is something like this. Yes, this is the effective throat thickness. And this effective throat thickness is what? It is K into S. It is nothing but K into S. Very good. K into S, right? Now this K depends on what? The fusion angle. The K depends on the fusion angle, right? The angle between these two surfaces. Okay, this angle between the two surfaces. So when this angle is between what? When this angle is between 60 to 90 degree, then I will take the value of K as 0.7. Yes, when it is from 91 degree to 100 degree, I will take this as 0.65, right? Then 101 degree to 106 degree, I will take this as how much? 0.6, right? And then 107 degree to 113 degree, I will take how much? 0.55. And then 114 degree to 120 degree, I will take that as how much? 0.5, right? And you can see that this K is decreasing by how much? You see, it is decreasing by what? 0.5, 0.05, right? You can see the decrease is what? 0.05 and 0.05. Like this, you can remember the table. Like this, you can remember the table. Now, in the question, if you see, in the question, nothing is mentioned about the fusion angle. When such a thing is there, you can assume it to be what? 60 to 90 degree. This I can say is the default value. This is what? The default value, right? So as per that, the K is 0.7 and the size of the weld is given. So I can say the throat thickness will be how much? 0.7 into 8, that is how much? 5.6 mm. So I can say that the last option is correct. So I can say this option is correct. No problem. But what about the other options? Let us understand that. Now when I say the strength of the weld, it's the load required. When I say the strength of the weld, yes, it is the load required. So you are going to apply a load like this. Okay, you are going to apply a load like this. So it is the load P required for the failure of the weld. Now load is what? What is load? Load is stress into area, right? So here I can say design shear stress in weld, okay, into area of weld, right? Load is what? Load is your stress into area. Yes, stress into area. Now see, what is the formula for finding the finding the design shear stress of weld? Remember this formula. It is nothing but Fu by root 3 gamma mw. So this is the way we find out what? The design shear stress. Fu by root 3 gamma mw. Now gamma mw is what? Is the safety factor for weld. And this is 1.25 for soft welding if you are doing the welding in soft. And this is 1.5 if you are doing the welding in what? If you are doing the welding in the field. Now nothing is mentioned in the question. So you will assume what? You will assume soft welding. Now how to find out the Fu? You see the steel is given Fe410. For Fe410, remember that the Fu is how much? Fu is equal to 410 MPa and Fy is equal to 250 MPa. Yes. So you got your Fu, root 3 and gamma mw. Now tell me, what is the design shear stress you are getting? Tell me. What is the design shear stress you are getting? Tell me. What is the design shear stress you are getting? Tell me. What is the answer to find this design shear stress? Are you getting this value? This is, suppose I am putting the value 410 divided by root 3 and divided by 1.25. How much are you getting? Tell me. 189.37, or approximately I can say you are getting 189.4 Newton per mm square. Yes, you are getting this value, right? That means your option B is also correct. Your option B is also correct. Now coming to the strength of weld. When you are finding the strength of weld, you have already got your design shear stress. Now area of weld will be what? It will be the length of weld and then what? The throat thickness. This will be the area of weld. Area will be what? Length into thickness. Length into thickness. Now tell me what is the length of weld, seeing this question. From the question, tell me what will be the length of weld. Tell me. What will be the length of weld? From the question, tell me what is the length of weld. From the diagram, tell me. From diagram, tell me what is the length of the weld. 220 mm. Yes. 80 plus 80 plus 60. That is how much? 220 mm. Right? And your throat thickness also you got. So if I want to find out the strength of weld, if I ask you the strength of weld, how to find out strength of weld? Very easy. The strength of weld will be equal to, it's a load basically. So stress you got 189.4. Then area of weld will be what? The length 220. And then the effective throat thickness you got how much? 5.6. Now you see this is in Newton per mm square and this is in mm square. So you'll get in Newton. To find out in kilonewton, what you will do? You will divide by 10 to the power 3. So how much kilonewton you are getting? You are getting a value of 233.3 kilonewton. So this is the strength of weld. Whereas in the question is given what? 263.3. That means what? This option is wrong. Yes, this option is wrong. The strength of weld is not 263.3. It is how much? It is 233.3. So the next thing they have asked is, for a factored load of 350 kilonewton, the length of weld, you have to find out the length of weld if the factored load is 350. See, some length of weld is given. Yes, for that we'll get some strength. Now if I want to take the load of 350, you see, when the length of weld was 220 mm, I was getting the strength how much? 233.3. That means what? I can take a load of 233.3. If I want to take the load of 350, then what will happen? Then I have to increase my length of weld, right? Yes. Or I can say if I want to take the load of 350 kilonewton, I have to make my strength of weld equal to that load. Yes or no? I have to make my strength of weld. What my means the weld equal to what? The load. Yes. So in this case, what will happen? This will be the stress into area. In area, the length of weld will change. The throat thickness will remain same. Yes. So from here, can you give me the length of weld now? Can you give me the length of weld? The new length of weld when the load has to be 350. Because with the length of weld of 220, I can take only 233.3. If I want to take more, I have to increase. So how much length of weld you are getting from this equation? Tell me what is the answer? How much are you getting? Tell me. You're getting a value of 330 mm. Approximately you can say it will be 330 mm. Yes. You see at 220 I am able to take to 33.3. If I want to take 350 kilonewton, I have to go for what? 330. I have to increase the length of weld. So I can say this C is also correct. Understood? So this was a very simple straightforward question from where? From your welded connection first question. Let us go to the next question. Okay. Let's go to the next question. Okay. So this question is about what? Eccentric welded connection. This question is about what? The eccentric welded connection. Yes. You can see that two views are given to you. Suppose there is a load acting here. There is a load acting here. Okay. And suppose the load value is 200 kilonewton. Yes, this load value is 200 kilonewton. Right. And suppose it's acting at a distance of, this distance is given to us as, okay, suppose this distance is given to us as 80 mm, right? This is a plate welded to what? A I section. And this is welded like this is the weld. And this weld is given how much? It is given 150 mm. So you can see, if I see from here, I am getting this view, right? Yes. You will see the plate and these two welds are there. You see, these two welds are there. Yes, this is 150 mm. This is 150 mm. The size of the weld is given as 10 mm. Okay, the size of the weld is given as 10 mm. Now for this, some options are given. Options are given. It is an MSQ question, multiple select question. They have asked the equivalent shear stress. They have asked what? The equivalent shear stress, and also there is question on the bending stress. So how to find out this thing? Let us see. First of all, let us understand. You see, if I draw the weld section, it will be two rectangles, right? You see, one rectangle will be like this, another rectangle will be like this. The weld section will be something like this, right? Yes. Now, this thickness of the weld will be the throat thickness. Now tell me, what will be the throat thickness? Tell me. What will be the throat thickness? Tell me. What will be the throat thickness? Tell me. What will be the throat thickness? Please mention in the comment section. What will be the throat thickness? Please mention in the comment section what will be the throat thickness. 7 mm. Yes, throat thickness will be, nothing is given. You will take 0.7 S. That is equal to how much? 7 mm. Right? That is equal to 7 mm. So this is 7. This is also 7. Yes. Yes. So this is the weld section. Only draw the weld section or weld area. Only draw the weld section or weld area. And this dimension will be how much? 150. This dimension will be 150 mm. Right? Now see, the load acting is 200 kilonewton. If you transfer the load here onto the weld like this, if you transfer the load, so whenever there is transfer of load, what happens? Whenever there is transfer of load, there will be a moment, right? And what will be the value of this moment? The value of this moment, M, will be equal to how much? This load into this eccentricity, right? The load into eccentricity, right? Suppose this is E. So this will be what? P into E. So there is a bending moment and there is a force P acting on the weld. Now the force P acting on the weld, it will act as what? It will act as shear. You can see it is passing parallel, right? It is parallel to the weld area. So this P, due to P I can say, there will be what? There will be shear stress in weld. Yes or no? Due to P, there will be shear stress in weld, right? And how to find out shear stress? Very easy. What is stress? Stress is force by area. So I can say this shear stress will be what? The force by the area. Now area of what? Area of weld. Because we are finding the stress in weld, na? So to the area of the weld. Now if you see this weld, this weld is 7, 7 and 150. If you combine, they will form one rectangle, right? They will form one rectangle, right? Yes, they will form a one rectangular area. And this will be how much? This will be 150 mm, right? And this will be 14 mm, right? This is the weld area. This will be the weld area, right? This will be the weld area, right? Yes, this will be the welded area. Nice. Now, it's very easy to find out shear stress. What is force by area? What is the force? Force is how much? What is the force? Force is how much? Force is given as 200 kilonewton, right? So 200, if I want to find the stress in Newton per mm square, so I'll convert into Newton. So 200 Newton divided by area. Area is what? See this area, na? This rectangle. What is the area of this? Simply 14 into 150. No need to remember so many formulas. Just by understand diagram, you can solve the question, right? Yes. 7, 7, 14, 150, right? So how much shear stress you are getting? Tell me. How much shear stress you are getting? Vivek is writing 95.23. Others? 95.23. Very good. We are getting a value of 95.23 Newton per mm square. So this is the shear stress I am getting. Now due to the moment, this is the bending moment, right? Due to bending moment, yes, due to bending moment, how much? This is P into E, right? Due to bending moment, what I get? Due to bending moment, I get bending stress, right? I get bending stress. I'll get bending stress. Now that bending stress, what is the maximum equation of bending stress? Suppose FB. The maximum bending stress is nothing but M by section modulus Z, na? Remember, this is from strength of material, right? Strength of material. The bending stress, maximum bending stress is what? The bending moment by what? The section modulus, right? Now bending moment equation is what? P into E. Now P is how much? 200 kilonewton, so I'll convert into Newton. And E was how much? E was 80, na? See? E was 80, na? You see? E is 80 and P is 200 kilonewton. Right? Then we have Z is the section modulus. Now we have a rectangular weld, right? Weld area. Now for a rectangular weld area, what is the section modulus? Please write in the comment section. For a rectangular rectangular area, what is the section modulus equation? Can you tell me? For rectangular, what is the section modulus equation from strength of material? BD square by 6, BD square by 6, BD square by 6, very good. So this is the B and this is the D, simple. Strength of material, right? So BD square by 6, so B is 14, D is how much? 150, BD square by 6. So can you give me the bending stress? The bending stress which is arising due to what? This particular bending moment. Please tell me the bending stress, tell me, come on. Tell me bending stress. 304.76. I am getting 304.76 Newton per mm square. So everybody understood how we are finding the shear stress, how we are finding the bending stress. No need to remember a lot of equations. From the basic equation of strength of metal, you can solve this question, right? Simple, very simple. You see, this is the weld area. Once you get the weld area, what is the shear stress? Shear stress is load force by area, very easy, right? What is the bending stress? M by Z, yes. Then we have the equivalent shear stress, right? Then we have the equivalent shear stress, or I can say resultant shear stress. Now what is the formula for that? Remember this formula given in the code, that is FB square plus what? 3 times Q square. Very easy formula. So using this formula, your FB is what? 304.76 square plus 3 into Q square. Q is how much? 95.23 we got something, right? Let me see. 95.23. Okay. Now give me the answer to find out what the equivalent shear stress. Give me the answer, the equivalent shear stress. Very easy. Equivalent shear stress is nothing but the resultant shear stress. And this is the way we find out. I can say the resultant or the equivalent shear stress is due to what? The combined effect of the bending stress and this. So we are getting how much? 346.53 Newton per mm square. So this is the equivalent stress we are getting. Understood? So very standard question which they can ask, right? Okay, now coming to the options. Equivalent shear stress is given 346.53. That is correct. If this is correct, obviously this is wrong, right? And the bending stress in the weld is how much? 304.76. So this is also correct. So that means this is wrong. Yes. So I can say in this both A and C are correct. Both A and C are correct. Okay. And here I can say is that your B, C, D are correct. So we solved 2 questions from where? From the welded connection. Let us solve question from what? From bolted connection also. From bolted connection. Okay. So this is eccentric bolted connection. Okay. Let me write down the question. Write down the question. In this, we have a load acting. Okay. Eccentric bolted connection. We have a load acting like this. This is 250 kilonewton. Okay. Let me use the scale. Hope you're all enjoying this lecture. Yes or no? Are you all enjoying the lecture? Please write down in the comment section. Are you enjoying the lecture or not? So then let me draw the diagram properly. Okay, very good. You see, this load is given 250 kilonewton and it is acting at a distance of how much? This is acting at a distance of 100 mm from the centroid. Very good. This is the centroid of this weld, this bolted connection. There are 6 bolts. The 6 bolts are there. Okay. Let me name the bolts. The bolts are, this is A, okay, this is B, this is C, this is D, this is E, and this is F. So 6 bolts are there. Okay. Now the distances are also given. This distance between these bolts is given 120 mm. Okay. And this distance is given as 160 mm. This is given as how much? 160 mm. It's a very important question. You can expect one sure shot question from this. This is what? 160 mm. Very good. Very nice. Now it is given that this bolts are experiencing what? Forces. Which force? 250 force you are experiencing. Very good. Now some things are written. Resultant force on bolt A, then resultant force on bolt B, and the maximum resultant force experienced by which bolt, and resultant force on bolt E. So many questions are given, right? So many questions are given. Now, see, when I shift this particular load, okay, when I shift this particular load, what will happen? There will be a moment, right? There will be a moment. So the force is shifted 250 kilonewton, and then there will be a moment also, right? And this will be a twisting moment for all the bolts, right? You can see this particular moment will be a twisting moment for all the bolts. It will be what? A twisting moment for all the bolts. And this twisting moment torsion T, yes, this torsion T will be how much? This force P into this eccentricity E, P into E. So there will be what? There will be two things, right? One, there is the force transfer, yes, and then there is torsion, right? Now on each bolt, I can say on each bolt, what will happen? There will be direct shear due to this load. Yes, this load P has got transferred, right? Now this load P will be equally distributed among all the bolts. So I can say on each bolt there will be a force F1, right? Which will equal to what? The total load divided by the number of bolts. Now tell me what will be the force F1? This is the direct shear force. This is the direct shear force due to the load P. What will be this value? Tell me. What is the value of direct shear force on each bolt? Can you tell me? Direct shear force on each bolt at SGS 41.67 because total load is 250 and there are 6 bolts. So 250 by 6, I will get 41.67. 41.67 kilonewton. Very nice. This we understood direct shear force. Now coming to, there is twisting also, right? There is twisting also. So due to twisting, yes, or torsion, there also will be a shear force. And due to twisting T, twisting moment T, I can say, due to twisting moment T, I can say that the force F2 will be generated. This is what? This is shear force only, but this is due to what? Shear force due to torsion or twisting, due to T. And this formula is what? This is P into E, the radial distance of that particular bolt, divided by what? Summation of all the radial distance. Divided by what? Summation of all the radial distance. Now coming to this force P we know, eccentricity we know. Now what about the radial distances? See here, this is the center of the bolt. The center of the bolt, right? Very good. You can see that the center of the other bolts. Now you can see that they are having a particular distance, right? They are having a particular distance from the center of the whole bolt section, right? From center of the whole bolt section, right? They are having a particular distance, right? Yes. And this I can say are the radial distance. Because this was bolt A, this was bolt B, this was bolt C, this was bolt D, this was bolt E, this is bolt F. Can I say this radial distance will be RA, this radial distance will be RB, this radial distance will be RC, this radial distance will be RD. Now you can see that all these radial distances will be same, na? RA is equal to RC, okay, is equal to, sorry, it's not RB, actually it is RF, sorry, yes. RA is equal to RC is equal to RD is equal to RF, na? Yes, they will be same, na? And how to find out this? Very easy. You see, this is 160, total is 160. So I can say center will be how much? 80, na? So I can say this dimension will be 80, na? Yes or no? This will be 80, yes. Half of it 80. And this one will be how much? This is 120. So this distance will be how much? This distance will be half of that. This will be 60, na? Yes. So if you see, a triangle is formed. Now can you give me this radial distance? Tell me the radial distance. RA is equal to RC is equal to RD is equal to RF. Tell me the radial distance R, this value, how much you will get? Tell me. 100 mm? Yes, very easy. Root under, I can say 80 square. It's right angle triangle, right? So 80 square plus 60 square, I am getting how much? This will be 100 mm. 100 mm. Now see, for RB it is different, na? For RB and RE, the radial distance is different, na? Can I say for RB and RE, what is the radial distance? Tell me. For RB and RE, what is the radial distance? Tell me. For RB and RE, what is the radial distance? Tell me. For B and D, or I can say. It is 60. Yes, it is 60. It is 60. Yes, it is 60. So when I say to find out the summation of R square, when I say to find out the summation of R square, it will be what? It will be RA square plus RC square plus RD square plus RF square plus RB square plus RE square, right? And this I can write down as what? 4 into 100 square, right? 4 into 100 square plus 2 into 60 square. So how much you are getting? The summation of R square, tell me. The summation of R square, tell me how much you are getting. Summation of R square, how much you are getting? Please tell me, write in the comment section. Yeah, I am getting 47200 mm square. This is what? The summation of R square. This is how you find the summation of R square. Now coming to this formula. Now F1 was same for all the bolts, na? You see? F1 was same for all the bolts because it was equal distribution. Now F2 is depending on what? F2 is depending on radial distance. That means F2 will be different for different bolts. So I can say for A, C, D and F, you see the corner bolts. A, C, D and F, right? A, C, D and F. What will happen? What will happen to them? For them, what will be F2? You will put the value of this load, which is 250 kilonewton. I'll convert into Newton. Eccentricity was 100. 250 na? Yeah, 250. 100. And then the radial distance for this bolts is how much? 100 na? So I'll put 100 divided by summation of R square, which we got how much? 47200. So tell me, what is the F2 for these bolts? What is the F2 for these bolts? Tell me. What is the F2 for this bolts? Tell me. Write in the comment section. What is the F2 for this bolt? Tell me. Write in the comment section. 52.96 you are getting. Getting how much? 52.96 you are getting. Yes, for these bolts. Now for B and E, you see, for B and E, what will happen? The radial distance is different, na? So what will happen? P will remain same. That will be 250 10 to the power 3. Then E will be same, 80 only, not 80, sorry, 100 only. But the radial distance will be different. I'll take how much? 60 here. But the summation of R square will be same because that is for total one. So what is the F2 for B and E? Tell me. What is the F2 for B and D? Please mention in the comment section. F2 for B and D. Please tell in the comment section. F2 for B and D. Please write down. $31.78. So everybody understood. Now everybody understood how we are finding the F1 and F2 for each bolt. Yes or no? F1 and F2 for each bolt. Okay. Now let us analyze them. Let us analyze them. You see, what will happen? This F1 force will be all downward, right? This F1 force will be all downward. Why? Because this F1 force is due to this total load P, right, which has got distributed, right? This total load P was 250 kilonewton and it has got distributed, and therefore what has happened? Therefore what has happened? This all F1 forces which are same will be acting downward. Will be acting what? Downward like this. Yes, very good. Now coming to F2 force, remember F2 force will be always perpendicular to the radial distance. So this is the radial distance. So F2 force will be like this, right? You see, this is the radial distance, F2 force will be like this. This is the radial distance, F2 force will be like this. Yes, this is the radial distance, F2 force will be like this, right? This is the radial distance, F2 force will be like this. This is the radial distance, F2 force will be like this. So again I will draw. This will be the direction of F2 force. See, perpendicular to radial distance, right? You see all the F2 forces directions I am drawing. Yes, perpendicular to what? Perpendicular to the radial distance. Yes, you see, very simple, na? Simple, you see. I am applying a twisting moment like this. Yes, let me just erase this. I am applying a twisting moment like this. I am drawing some other ink, yes. I am applying a twisting moment like this. So, the forces will act like this or not? Tell me, everybody. The forces will act like this or not? Tell me, everybody. Yes, na? Yes. So, these are direction of what? F2. Direction of what? F2. Yes. Now, see, if I want to find out the resultant for the A bolt, you see, F1 is acting like this for A bolt. F1 is acting like this, F2 is acting like this. Yes or no? F1, F2. And this is the angle theta. Is the angle theta. Now the resultant force equation is what? Parallelogram theory. Parallelogram theorem, what? Simply F1 square, yes, plus F2 square plus what? 2F1 F2 cos theta. 2F1 F2 cos theta. Now F1 for bolt 1 is 41.67. Actually F1 is same for everyone, na? Yes, and F2 was how much we got? F2 we got as 52.96. This we got as 52.96. Now what about cos theta? I need this cos theta, right? What about cos theta? Very simple, you see. If this is theta, this is also theta, na? This theta, na? I am enlarging diagram, you see. This is F1, this is F2. This is F1 and this is F2, right? Okay. F1, F2. Yes. If this is theta, yes, this is theta. This is also theta. So what will be cos theta? Can I say this dimension was how much? Tell me. This dimension was 60, na, remember? And this was 100, na? In this triangle I can say. So what will be the value of cos theta? Is the value of cos theta is equal to 0.6? Yes. Is the value of cos theta is equal to 0.6? Right? Yes. So you see, one thing you can understand from this, that steel structure is not tough. It is very logical, right? Just you have to put some energy. If you spend some energy, it's very easy to solve, right? Very easy to solve. It's fun actually. Okay. Now, FR will be equal to how much? Tell me for A bolt. You can find out the value and give me the answer. It is, you can see, just put the value and give me the answer. Okay, everything is there. Give me the resultant value for bolt number A, for bolt A. 84.79, okay. Almost 84.8 kilonewton. So this is the resultant for A bolt. This is the resultant for what? A bolt. Yes. So I can say that in my options, the first option is correct at least. The resultant for bolt A is 84.8. This is correct. Now coming to bolt B. You see this bolt B, if you see, this is the bolt B now. You see in this bolt B, the F1 and F2 are in same direction na? Huh? You see? For this bolt B, this F1 and F2 are in same direction na? So can I say for bolt B, the resultant will be simply what? Simply equal to F1 plus F2 ra? Huh? Yes? So how much you will get? For bolt B, but bolt B, F2 is different na? F1 is 41.67. What is F2 for bolt B? For bolt B, F2 is 31.78. Yes, 31.78. So how much are you getting this? How are you getting this? FR, tell me. How much are you getting this? For bolt B? Because for bolt B, F2 is different. For bolt B, F2 is different. F1 is same. Okay, so how much you're getting this value? Tell me. What's the answer to FR? $73.45 you are getting. Yes, for bolt B, this is the resultant. Why we are getting resultant? Or I can say, can I say the angle is 0 degree, right? Between F1 and F2, angle is 0 degree. So what will be cos 0? Cos 0 is 1, na? So when you put this F1 square plus F2 square plus 2 F1, F2, it is what? F1 plus F2 whole square. Square root of that will be F1 plus F2, right? Yes, you can see in that manner also. Yes, because they both are in same direction, I can say I can just add them up. But F2 is different. Yes, so I can say now that this is how much? I can say second option is wrong, right? The second option is wrong. The resultant on bolt A is bolt B is not 64.9. Now coming to this C bolt, you see this C bolt. For this C bolt, this angle will be again theta, na? For this C bolt, this angle will be theta. Yes, F1 is how much? F1 is your 41.67 only, and F2 is also 52.96 na, because whatever results we got for A, same results we got for C also na, F1, F2, and angle is theta also. So can I say this resultant will be applicable for A bolt also and C bolt also? Yes or no? This result will be applicable for A bolt also and C bolt also. So I can say for both A and C, since you can see the angle is same, the angle is theta only, and F1, F2 are same, so I can say I will get the same results. I'll get the same results. Okay. Now coming to this E bolt first, and then I will discuss about D and F also I will discuss later. Okay, but let me first come to this E bolt. This is the E bolt. Okay, this is the E bolt. Na? So for this E bolt, you can see that for this E bolt, this F1, F2 are in opposite direction. Na? Yes. For this E bolt, the F1 and F2 are in opposite direction. So can I say for this E bolt, what will be the resultant? It will be simply equal to what? F1 minus F2. Yes or no? It will be simply what? F1 minus F2. Yes. So how much you will get? Tell me value. And you see for E bolt, F1 will be 41.67 only, and F2 will be 31.78 now, because B and E are same. B and E are same, so I am getting almost what? 9.9. I am getting how much what? 9.9. Because for B and E, F1, F2 is same. Just what happened? For B we added, for E we are subtracting. Yes. So it is 9.9 and given option, yes, the last option is correct. The last option is correct. 9.9 is correct. Very good. Yes. Structures is actually easy. Now tell me, is it tough? Yes, you can say that, yes, sir, we have to understand. Understanding, obviously, you are going to be engineers. Now you have to understand. Yes. Steel structures, concrete structures, and structures are not tough. You have to just put some energy. If you put some energy, it is fun actually. Yes. It is fun. It is fun. Now you see, coming to this, maximum resultant force is experienced by bolt A and C. Let us see that. Let us see this correct or not. This correct or not. Tell me, you see. Here we got the resultant force for what? We got the resultant force for A and C. For A and C, how much we got? 84.8. For B, we got 73.45. For E, we got 9.9. Yes. Now coming to this D and F bolt. Coming to this D and F bolt. I will redraw it here, you see. The 6 bolts I will draw again, okay? Yeah. Now see, this is the radial distance for the first bolt. F1 was down and then F2, right? And this was theta, so this was also theta, right? And for this bolt, F1 was like this and F2 was like this. F1, F2. Here also the angle was theta only, right? By symmetry I can say the angle was theta only, right? For this bolt, F1 and F2 were in same direction, right? So we just added. And for this bolt, what happened? F2 and F1 were in opposite direction. So what we did? We subtracted. Easy, no problem. Everything was fine. Now coming to this D bolt and F bolt, if you see clearly, you see this is the radial distance, and you see F1 will be acting downwards, yes, like this, and F2 will be acting like this. F2 will be acting like this. Yes or no? F2 will be acting like this. Yes. Now see, by symmetry I can say this will be theta. So this will be 90 minus theta, na? Yes. This will be what? 90 minus theta. And this is 90 degree. This is 90 degree. So can I say for this F bolt, can I say for this F bolt, the angle between F1 and F2, for F bolt, the angle is how much? Angle between forces is 180 minus theta, right? Everybody is convinced? The angle is 180 minus theta. And similarly here also we can see that by symmetry I will say, in this D bolt also, you see, this D bolt also I can say that this angle will be what? Same 180 minus theta. Yes. So for bolt F and bolt D, it will be 180 minus theta. But the value of F1 and F2, will be same as we got for what? A, C, yes, because you see for A, C, D, F, F2 is this, and F1 is anyhow same for all the bolts. But F2 is same for A, C, D and F. Yes, but what is the difference? The difference is for A bolt the angle was theta degree, na? For C bolt also the angle was theta degree. But here for D and F the angle is how much? 180 minus theta. So when you're finding the resultant, it will be what? F1 square plus F2 square plus 2F1 F2. In place of theta you write down what? 180 minus theta. And cos 180 minus theta is how much? Minus cos theta. So this will become F1 square plus F2 square minus 2F1 F2 cos theta. Yes or no? Minus 2F1 F2 cos theta. Yes. So you see, if you compare the AC to D and F, F1 F2 is same, but the angles are different. There it was plus cos theta, here it will be minus cos theta. Why? Because the angle was 180 minus theta. So what will happen? What is the answer to this? Tell me. It's not asked in the question. It is not asked in the question to find a resultant of F and D. Suppose I'm asking you extra. So can you give me the value? F1 square is 41.67 square. Then F2 will be same, which we got, that is 52.96 square. Okay. And then what will happen? Then you'll subtract minus 2 F1 F2 cos theta is 0.6, right? Cos theta is anyhow 0.6. So tell me this value. FR how much are getting? FR how much are getting? How much are getting? F1. FR for this bolt F and D. See, this question is very important for your steel structures. There is very high probability that they will ask a questions from this. Yes, 43.5. So as it is suggested, please subscribe to the channel. Now we have only one channel, right? Now we have only one channel, that is the BYJU'S Exam Prep Civil and Mechanical. So all the English sessions will be also conducted on this platform only, on this particular channel for Civil Mechanical. So if you have not subscribed, okay, if you have subscribed to the old channel, very good. Don't unsubscribe, but subscribe to this also. So 43.5. So now tell me, is the option C correct or wrong? Tell me. Is the option C correct or wrong? Tell me. Is the option C correct or not correct or wrong? Tell me. Correct. Correct. Yes. Always remember. Always remember. What you should remember? Always remember that for these corner bolts, which are near to the load, you will get the maximum shear force, maximum resultant. You will get the maximum resultant. You always get the maximum resultant. Yes. Suppose I have 4 bolts like this. I'm just drawing 4 bolts like this. A, B, C, D. Where I will get the maximum resultant, tell me. Suppose I have 4 bolts like this. Tell me where I will get the maximum resultant, which bolts, and load is acting like this, somewhere here. Where I'll get the maximum resultant, tell me. In this arrangement, if there are 4 bolts arranged like this. Maximum resultant. Yeah, A and B, and B, and B. Corner bolts near to the load. You see what will happen here? Same thing will happen, you see. Same thing will happen. F1, F2, F1, F2, F1, F2, F1, F2. The angle between the forces F1 and F2 for C and D will be how much? 180 minus theta. So always that negative term will come into picture. And here it will be theta. So remember, corner bolts close to the load. So here what happens? Corner bolts are A and C, right? They are close to the load. No need to find out the value of, see here we found out F and D, that is additional thing. There was no need to find. Was there any need to find out for F and D? There was no need. I just explained you how to find out. But as per the question, there was no need to find for F and D. You should remember that for this arrangement, the corner bolts which are near to the load will have the maximum resultant. Understood? Very good. Let us solve the last question for today. Okay. So actually I am covering many things, right? Okay. I am covering many things. Okay. So this is, we can say 2 plates are joined. Okay. This is 20 mm plate. Okay. And this is a 16 mm plate. Okay. And you can see some packing plate is also placed. Packing plate is also placed. 2 plates are connected like this. And these are the main plates. What are the other 2 plates mentioned here? What are these plates? Suppose these are 6 mm plates. What are to 8 mm plates? What are these? Tell me. What is this? Tell me. What is this plates? This 10 mm plates. What are these 10 mm plates? What are they known as? What are they known as? What are this? Tell me. What is this? Huh? What are these 10 mm plates known as? And then you have bolted, okay? Suppose you have bolted here. कवर प्लेट या भूल गया forgot forgot. Okay, now you remember, very good. Double cover butt joint, very good. Yes, yes, double cover butt joint. So these are what? Cover plates. They are main plates. Okay. And some additional data is given. Add the data. The bolts are M20 bolts. M20 means the diameter is 20 and they are of grade. They are of grade 5.6. They are of grade 5.6. Yes. And then the plates are, these are for the bolt. There's a bolt specification. The plates are FE410. Okay. And then the end distance is given. Ease end distance is given how much? 55 mm. And the pitch is given as 80 mm. All this data is mentioned in the question. And they're asking you 2 things, right? Shear strength and your bearing strength. Shear strength and bearing strength. Let us find out them. Shear strength and bearing strength. See, when I'm finding the shear strength of bolt, okay? When I'm finding the shear strength of bolt, right? Shear strength of bolt. Now it's a strength means what? It's the load. Now the shear strength of the bolt will be what? The shear stress we can say design shear stress in bolt, design shear stress in bolt, right? Into what? Into the shear area, yes or no? Into what? The shear area. This will give me what? The strength. Strength is a load basically. It is in kilonewton. It's a load. And then we can say the notation is BDSB. We can say design shear strength of bolt. You can say design shear strength of bolt. Okay. So now, how to find out the design shear stress in bolt? It is very similar to what we have done in the weld. For weld, it was how much? Fu by root 3 gamma mw na. So here it will be, instead of Fu, it will be FUB because finding for the bolt. And then this will be gamma mb. It's very easy. So this will be what? This will be the design shear stress in bolt. Now if I want to find out the design shear stress in bolt, the area will see later. The area will see later. Don't worry, don't worry. Now, this is given what? Grade 5.6. Bolt is given how much? Bolt is given grade 5.6. Now what? How to find out the FUB? Very simple. You take this 5 first before the decimal, yes, and multiply 100. This is the way you find out what? The FUB. This is the way you find out the FUB, the ultimate strength of a bolt, right? And then if I want to find out FYB, how to find out? Remember that the ratio, see FYB, the yield strength was not required, just for some other question. This is equal to the remaining, that is what? 0.6. So from here I can say FYB will be how much? It will be equal to 0.6 into 500, giving me how much? Giving me 300 Newton per mm square. Yes. So this is from the grade how to find out the FUB and FYB. From the grade how to find out what? The FUB and FYB you should be knowing. Yes. So you can put this value. FUB is how much? We got 500 by root 3. Very similar to what we have got in your welded connection, right? Shear stress. Only Fu by root 3 gamma mw here. And gamma mb is always 1.25. Remember, gamma mb is always 1.25. Yes. So how much this stress you are getting? Tell me. How much your stress you are getting? Tell me. How much stress you are getting? Tell me. This stress how much you are getting? Let me find out also. 500 divided by root 3 and then further divide by 1.25. I'm getting 230.94. I'm getting 230.94. Okay. This is the shear stress, Newton per mm square. Now coming to area. See, very easy, you know. Remember formulas logically. Don't remember formulas like, mugging up, logically. Strength of bolt, just what? Stress into area. So shear stress, area. You see, here there are two shear planes. You see, this is one shear plane and there is a second shear plane where the bolt can fail, right? Where the bolt can fail. Yes. So I can say the shear area will be, you see, there are two shear planes, right? Two shear planes. Now each shear plane will have certain area. Yes. Now what will be that area? That depends on, you see, if you say typical bolt na, if you see a typical bolt, then bolt will have a shank and then a threaded area. Like this, we'll have a shank and a threaded area. Now, from the diagram, it is not clear that this shear planes where there is failure, it is passing through the shank area or the threaded area, or I can say gross area or net area. In that case, assume it is passing through the threaded area or the net area. So I can say the shear area will be 2 into the net area of bolt. Why 2 into net area of bolt? Because there are two such shear planes, right? There are two such shear planes. Now we will take, so there is another bolt also, na? But we are finding for each bolt. For each bolt, 2 are there, right? Now should remember that this net area of bolt is 0.78 times of what? The shank area of bolt. This net area of bolt is 0.78 times of what? Shank area. But you see this? You see, obviously this area will be more, na? This is the shank area. Okay, this is the shank area, and obviously the threaded area will be less, na? So this is how much? It is given 0.78 times of the shank area, and shank area will be how much? Circular cross section. So simply pi by 4 into d square, right? Pi by 4 into d square. So I can say the shank area will be 2 times the net area of bolt, and net area of bolt is how much? 0.78 times of pi by 4 into d square. Understood? So here it will be 2 into 0.78. Okay. Then pi by 4. What is the diameter? Diameter is given how much? M20 means what? The meaning is diameter is 20 mm. The meaning is what? Diameter is 20 mm. So 20 square. So what is the area you are getting? Tell me. What is the area you are getting? Tell me. The area you are getting is 2 into 0.78 into pi divided by 4 into 20 square. I'm getting how much? 490 point something, right? We're getting 490.1. I can take approximately, right? Are you getting this value? Are you getting this value? Yeah, 489 something. Okay, that is okay. Okay, this much I am getting, and this will be in mm square, na? So if I want to find out, see, this answer will get in what? Newton. If I want to find out this thing in what? Kilonewton, I'll divide by 10 to the power 3. So tell me how much is the design shear strength of the bolt you are getting. Tell me, what is the final answer? The design shear strength of the bolt. How much you are getting? The design shear strength of the bolt, how much you are getting? Tell me. $113.2. You're getting how much? 113.2 kilonewton. Yes, 113.2 kilonewton. You see? So now from the given options, you can clearly see that the first option is correct and the second option is wrong. The shear strength of bolt is not 83.2, it is how much? 113.2. Now coming to the bearing strength. Now coming to the bearing strength of the bolt. The bearing strength of the bolt is given as BDPB, the bearing strength of bolt. It is what? The bearing, okay, strength of bolt. Okay. Now when I am considering the bearing strength of bolt, remember certain things. Now bearing strength of bolt will be how much? That will be the stress. You can say bearing stress. I can say that will be bearing stress. Okay, bearing stress into what? The bearing area. The bearing area. Very easy. Now what is the bearing stress? The bearing stress will be equal to Fu. Yes, it will be what? Fu into 2.5 kb by gamma mb. This is what? The bearing stress. Yes. So there is a factor called kb. There is 2.5 and there is gamma mb also along with this Fu. Now what is the difference? Here why I have written Fu. When I am finding the shear stress, I got how much? I was taking FUB now for the bolt, but in finding the bearing strength of bolt, I will take this of the plate. Very important. I'll take for the plate because the plate is actually applying the bearing. Why? You see, suppose this is the bolt. Okay, this is the plate suppose, and this is the bolt, right? The plate is applying the bearing stress like this, right? The plate is applying the bearing stress like this. I will take what? Fu and then few factors, 2.5 kb by gamma mb. I'll come to kb, don't worry. Now bearing area. Now bearing area will be what? If you see the top view, this is the bolt, and I can say this bearing stress is acting like this, right? Now this bearing stress will be acting on a projected area of this one, right? Or if I take the cross section, the bolt will be looking like this, na? The bolt is cylinder, na? Yes. So if this load is acting like this, can I say this load is acting on this projected area? Yes. The load is acting on this projected area, right? Yes. Suppose this thickness is T, okay, and this is the diameter D of the bolt, right? So can I say the bearing area will be how much? D into T. Everybody understood how the bearing area is D into T? How the bearing area is D into T, everybody understood? So you have to logically remember the formula. See, some things you have to remember empirical also, but everything should not be empirical. Everything should not be empirical. Some logic should also be there, right? So bearing area is D into T, right? Now T, which one you will take? Which plate? There are two plates, right? You will take the thinner plate. You will take what? The thinner plate, right? You will take the thinner plate. So there are two plates, 16 mm and 20 mm. I will take the 16 mm plate. Very nice. Now how to find out this KB? How to find out this KB? This KB is minimum of four things. One is E by 3 D naught. One is P by 3 D naught minus 0.25. Then we have FUB by FU and 1. Yes, the KB is the minimum of these four quantities. The minimum of these four quantities. Now when I am finding this E by 3 D naught, the E is given in the question, right? E is given how much? E is given 55, P is given 80, right? It is an M20 bolt, yes. So D naught is what? It's the hole diameter. D naught is what? It is the hole diameter. You see, this is the hole. Bolt diameter is 20. So obviously, the hole diameter will be little larger, right? And the hole diameter is your D plus 2 mm. Okay? And this is how much? 22 mm. Yes, 22 mm. Right? So when I'm finding this, yes, E is how much? E we got is 55 by 3 D naught. Means 3 into 22. So how much you're getting this E by 3 D naught? Tell me. This E by 3 D naught, how much you're getting? Tell me. This E by 3 D naught, how much you're getting? .833, right? We're getting 0.833. Yes. Now coming to this value, P is how much? P is 80. So 80 by 3 D naught minus 0.25. How much you're getting this value? Tell me. This P by 3 D naught minus 0.25. How much you're getting this value? Tell me. How much you're getting this value? Tell me. See, all these questions they will ask in the GATE examination. Okay. 0.962. Now FUB by FU. You see, FUB was how much? FUB was 500, na? 500 divided by FU. Here you see there is a small difference. You see, here there are two things. One is the bolt and one is the plate. For the plate we take FU and that is how much? 410. For the bolt I will take what? FUB, that we got how much? 500, right? So what is FUB by FU? I can say 500 divided by 410. I am getting how much? 1.22 I can say. I can getting how much? 1.22. So out of these four things, 1.83, let me just find out, 55 divided by 22 divided by 3, I am getting how much? 0.833. So minimum one is how much? 0.833, na? So this will become what? KB. So I can say what? KB is equal to 0.833. Now I can put this value, I can find out this BD, PB, right? Yes, I can just put the value. 2.5. FU will take how much? FU will take 410 because you take for the plate. 410, KB is how much? 0.833. Gamma MB is 1.25 and D is how much? D is 20 and D is the thinner plate. Thinner plate is 16. We'll get this answer in Newton because you see this FU is in Newton per mm square and D into T is in mm square. So Newton per mm square get Newton. So divide by 10 to the power 3 to get in kilonewton. So tell me what is the bearing strength of this particular bolt you are getting. Tell me. How much you are getting this bearing strength of the bolt? $218.6. Ladies and gentlemen, thank you very much for your great presence. These are the important questions, MSQ questions. And actually, if you see, I tried to cover many things. Yes, I tried to cover many things, but obviously everything is not covered. So if you want to see the other portions, important portions like tension members, compression members, beams, yes. And therefore, for them, please visit our app. We have taken a lot of lectures on them and you can always see them. So these are the important questions which we solved. Okay, now more questions for plastic analysis, shape factor, right? In plastic analysis we have two important topic. One is what? One is the shape factor, right? So shape factor, I have taken a video. Okay, please refer to this video. Okay, shape factor in plastic analysis, I have solved the shape factor for various shapes, very important topic from which they can ask questions. Also I have taken the collapse load in plastic analysis. This lecture is also available. Okay, you can always see, if you are finding difficulty to search, just Google Satyajeet Sahu and this name. Okay, just search what? Satyajeet Sahu, my name, and this particular video name, you will get it. Okay, so thank you very much. But some announcements. Tomorrow classes, okay, so a lot of classes are there tomorrow. Okay, so tomorrow in the YouTube channel, in the morning, this is tomorrow's schedule. Okay, this is tomorrow's schedule. So morning 10 a.m. so we'll have this shrinkage ratio class. Okay, please attend this class. At 9 p.m. we have we can say some important things I will discuss, how to boost your rank. I will give you some important tips. And then night 10:30, Abhinav sir will be teaching what? The longitude and time variation from the topic of subject of survey. So these are, we can say, tomorrow schedule, I can say. Okay, so please keep attending the sessions. Okay, and if you want to take the full courses, they're available in the BYJU'S Exam Prep official app. Download the app, you can search BYJU'S Exam Prep and that app will be available. There are also a lot of high quality videos are available and also you can see for yourself. Okay, thank you very much. Good night. Thank you. Bye.